Okay, sorry about the technical issue. So this is lecture 8. This is lecture 9. Okay. Okay. This is lecture 9. So I was planning to talk about this last time, but apparently we didn't have the time. So we used Pandas to read the CSV file last time. This time we use Xarray to read multi-dimensional data. Okay, it's very complicated. So I need you to pay attention this time. A lot more complicated than last time. Okay, so why do we need Xarray? We need Xarray to read NetCDF file. So it's specialized to store meteorological data. So you can see that we are plotting some temperature variable in a NetCDF file here. So this is an example. So what does it contain? It contains a lot of things. If it's just 1 and zeros, then you have no idea what your data is. So we have invented a way to include other information, for example, the variable names, so-called the metadata, okay? The metadata of your data, which means it's the information of the data. So the variable names, so that it's readable to a human being. And also we need to know the dimensions, because here you can only see 2D, two-dimensional data, right? So in the data, it's probably 3-dimensional or even 4-dimensional, right? So time, latitude, longitude, vertical level, so it's 4-dimensional here. And also, of course, the values of the data. So each of the points, what does it contain? And also the attributes, for example, temperature, there are many units for temperatures. For example, if your temperature can be saved in Kelvin, right? Kelvin degree or degree Celsius. So your attributes will store that. So the units of your data and your NetCDF file, the data can be plotted as a figure. And we use Matplotlib. We'll get to that in a later part of this course. So how do we visualize the data? So here is a simple graph, a schematic diagram showing you how an NetCDF file store the data. Okay, so first of all, we have to understand the numerical information. What does it mean by numerical information? The information with numbers, right, with data. So the data variables. So we just mentioned maybe it's 3D, maybe it's 4D, right? So it's like a multiple dimension matrix in here. Okay, and it can change with time, X, Y, Z, T. So apparently time is the dimension that you stack on, right? When you add more data, you're adding more data in the time dimension, right? And also the numerical data that does not change with time. Okay, so what does not change with time? The time, of course, does not change with time, right? When you add more data, you will have, when you go through your data, your time, the time variable does not change. It means that if it saved data, for example, for the whole month of July, then it's just saved for the whole month of July, right? It doesn't change. When you change the variable time, it doesn't change with time. And also latitude, longitude, elevation, meaning height. Sorry, this is the typo here. Oh, no, elevation is, sorry, it's not a typo. Elevation is the topography. So it depends on X and Y. Okay, and land cover also depends on X and Y because we only have one land surface. Okay, so here are the data that we have, the numerical information. Okay, so the coordinates are the time, latitude, longitude here. Okay. And also we need textual information or other information. For example, your variable name, it will be saved for each of the variable. Okay, for each of the variable, you have attributes. Attributes are the textual information. Variable name, units, precision, meaning to word, decimal place, right? Okay, and then we have attributes for the whole data set. For the whole data set, why do we need information? Maybe we need information to store where the data are measured, for example, or the data source, maybe from a certain institute, okay, or from a certain university. So the data attributes will save that. And also for the coordinate variable, for example, the time, latitude, longitude, it will also have some attributes. What would be the attributes? Of course, even for your coordinates, you will need units. For example, here, latitude, longitude, maybe they're in terms of meter, right? On the surface of the earth, maybe they're in terms of degree, right? Degree longitude or degree latitude. So you don't know that. If you want to know, you need to read the attributes. So in this lesson, we will get to the library, we get to the package of how we can read all these different variables. Okay, first of all, we need to, I don't think we need to install that, but I just put it here in case. To install the NetCDF library in your Google Colab. So I have given you the the script, including all the scripts I am showing in the slides. Okay, so this is not for your homework. This is for you to copy and paste when you do a homework. Okay, so here install your NetCDF and then import the library Xarray. Okay, and then okay, I've just talked about this. We import the Xarray library. And how do we read the NC file? So of course, we need to include the 4 lines for reading your Google Drive, and then import Xarray. And here is how we open a data set. Okay, this data, this NetCDF file .nc is included in the Blackboard. Okay. Okay, you can try that. Okay, and then put that in your Google Colab folder. Okay, and then we read that, and the data set will be stored in this data variable. So this data variable is an object storing everything. When you want to read the NetCDF file, you need to start with this. Okay, data. So when you print the data, it will not give you everything, or it will not give you all the variables inside. It will print the metadata for you. What is the metadata? All the attributes, all the coordinates. So when you print that, it will give you, it will tell you that, okay, it's Xarray data set here, Xarray object here, but it's not printing you the variables inside. So it's printing you the dimension, the coordinates, what data variables you have. Apparently you only have one variable in here, which is temp SFC in here. So probably surface temperature, right? And then the attributes of your data. And okay, all the attributes of the data. You can see that it's giving you some information, right? Just by reading this, you know that it's data from some model 4 times a day. So 4 times of data a day. And it's from an institute for ANCA, okay, in the US. Okay, and also you know the coordinates. There are only 3 dimensions: time, latitude, longitude, right? Time is giving you a range. It's not printing you everything, right? It's from the beginning to the end. So from January the 1st of 2017 to March 31st. Okay, and you know it's 4 times a day, so you can do the math. And you know how many time steps you have, so it's 360. It's also given by you. Okay. Latitude and longitude, you can have a lot of information from here too. So you have 73 points in latitude, 144 points in longitude. Okay, so just by reading this, you know that you know the spatial resolution of your data, right? 90 degree to 87.5 degrees. So what would be the spatial resolution here? Spatial resolution 2.5度啦，每一格2.5度喺度。Okay, 2.5 degree from one point to another point. Okay, and you know that the dimension of your data is time, latitude, longitude, right? 3 dimensions. Okay, so what are the dimensions? I just talked about this. So usually the data have different dimensions. For example, time and space. We just have time and space. Okay, time X, Y, Z. So for some variable, it doesn't need the height dimension, because if you are talking about sea surface temperature, it's just one surface, right? You don't need the height. So it depends on what data you're talking about. Okay, so we are talking about this part, the coordinates part. The time, in time, you will have it's discrete always, right? In your data, it's not continuous. So from one point to another point, that's your time resolution. So for this example file, it's 4 times a day. So what's the time resolution? 6 hours, right? 一日4次啊嘛，食藥咁，咪6個鐘食1次藥咯，係咪？ Okay. Okay, so the dimensions are named. So it's got name dimensions, time and space. The name of the dimension would be, of course, for time is just time, right? For space is latitude, longitude, and altitude, the height or the pressure. Okay, so different names. So here, I'm showing you a table of giving you some idea of how your data can be stored according to the dimensions and coordinates. So here, for example, if we have, I'm showing you the longitude of your data, and the resolution is 10 degree, right? Yeah, 10 degree. So the dimension is called longitude, and the coordinates are talking about the values, the actual values, 100 degree east, 110 degree east, so on and so forth. So the coordinates are the actual numbers. The name of the dimension is longitude. So here, I think you have to fill in your worksheet that I've given you last time. It's counted as the participation. Should be this. It should be this one. Okay, this slide 12. So you already know the answer, right? The size of your longitude is 5. So I've given you the option of filling in this one. So it turns out that if you have the data set object, right, data here, you can print all the names of the dimension by doing this data.times dimension, and then you get time, latitude, longitude, and also the size of it. It will print you the dictionary for that, okay? So please do this question. You have to give me the dimension and the size of each of the dimension. Okay. I'll give you, I think it's pretty easy, give you 1 minute or 2 minutes to do this. Okay, any questions in doing this exercise? The answers are not, cannot be found in this slide, it's in the previous slides, okay? So there are 3 dimensions here, and what would be the size? I think most of you can do it, okay? Okay, so if you want to, okay, even if you know the size, okay, it's for example, it's 100 in time, okay, and you don't know which time you're talking about, right? There are a lot of times before you and after you, right? So you don't know the time. So how do we get the actual time or actual latitude, longitude? So this is how we do it. We put the data set object here, which is data in this case, dot coords. Then you can print the values here. And of course, not all the numbers are printed. So it's like a simple version of all your coordinates. So it's printing the first one and the last one for you. And also a few numbers for latitude and a few numbers latitude in the beginning, a few latitudes in the end, so that you have some idea of the range of the data that you're talking about. So here latitude is from the North Pole, 90 degree, all the way to the South Pole, right? Not minus 90 degree. Okay, so it's doesn't necessarily has to go in the increasing order, right? When you talk about coordinates, most of the times when you save data, it's storing data from 0 to the infinity, right? It's from increasing from 0 to infinity. Here it's the other way around. It's decreasing the latitude. So it's from the top to the bottom. When you plot the data, sometimes it will give you a reverse version, because most of the computer, we think that, okay, you're printing from 0, starting from 0, right, to a certain value. So if you print that with a ordinary way, it will give you like a reverse map, right? The latitude will be reversed. So that's okay. So you have to remember this. Okay, for longitude, it's just normal way, starting from 0. Okay. So how do we, so the problem here is that you don't know everything, right? We don't know all the numbers. So how do we print all the numbers? So here is how we print all the numbers. Data dot coords, and then you specify which dimension. So you need to know the dimension name. That's why we need to know the dimension name. We know that the dimension names are time, LAT. Sometimes it's latitude, so it's the long version. And here LON. So you use LAT as the string and put inside your square bracket here. It will know that you want to print the latitude coordinates. So you're printing everything in here. So you know that, okay, now I have 73 numbers from 90 to minus 90, and in between is 2.5 degrees. Okay. And for this latitude, actually, it's a variable. It just doesn't change with time, right? So it's a variable in your data, and it will have some attributes even for your dimension. Okay, attributes is saving, for example, the units, the long name, and also the actual range. Some attributes in here. Okay, so attributes can be numbers, arrays, or strings. So it can be anything. Okay, so now we talk about the actual data. So here, the data variables. So the actual data, you know that we have 3 dimensions, right? So to understand the 3 dimensions, here is a graph showing you. So latitude, we have 73 numbers, 73 values, right? From 90 degrees to minus 90 degrees. And the longitude is 144 degrees. So the sizes of dimensions you have already filled in the question, right? And then you have different times. The first time in your data is 2017, January 1st. And then next is, because it's 6 hours, right? The temporal resolution is 6 hours. So the next one is January 1st, 6 o'clock. And then the next one is 12 o'clock, and so on and so forth. Okay. So here is how we understand the 3-dimensional data. Okay, so now we get to the part where we actually need the values. What values we actually need? Of course, the data, right? Okay, so when you print the data variables in here using data dot variables, it will give you more than one variable, even though you know that there is actually just one variable. The time, latitude, longitude are also variables, but they are coordinates variables. So they mean nothing to you, right? You just need them when you plot them on a map. Okay, so the actual variable is in here. When you print the data dot variables, it will not give you colors. I'm just highlighting that for you to understand easily. So it's kind of giving you this messy outline. So time is in here, latitude in here. So it's, I don't know why the format is messed up, because the actual range belongs to time in here, right? And right after that, they're giving you latitude, okay? And longitude and temperature, the surface temperature variable is called TEMPSFC. It's the name of the variable. So whenever you want to get this variable, you need to know the name. This is the name. This is a string that is storing the name of your data. Okay, so 4 variables. The first 3, they don't mean anything to you. So we just need this. So it's giving you the time, latitude, longitude, the dimensions. Sometimes you have multiple variables in your data and they will have different dimensions. Okay. For example, when you want, what if you want to store temperature and you also want to store, for example, sea surface temperature, right? Sea surface temperature, it doesn't have the height. So even for the same data, for different variables, they might have different dimensions. Okay, here is how you want to get to know more about your variable. Just put data and then square bracket and the name of the variable in here, TEMPSFC. Okay, and then when you print that, it will not give you the actual values. The actual values is giving you something. For example, here you have a certain values. Of course, it's a large number, right? 360 times 73 times 144 values of data, and it's giving you the data type, float number, and it's giving you the coordinates and the information, the attributes of the variable. Okay, so only print the info of your variable in here. It's not printing you the whole box of data in here. So how do we get a hold on this data and then do calculation afterwards? We'll get to that part. So next we talk about the textual information first. I think we have gone through a little bit. So the attributes of each of the variable, the attributes of the coordinates, and the attribute of the whole data. So there are 3 types of attributes in here. So the attributes of the data frame, if you want to print that, just type data.attrs, just like printing coordinates or dimensions, and then it will give you this. Just some textual information, description of the data. You might not understand these. So if you want to find more information, they're giving you the hyperlink, and this is the name of the data. So you can actually download that. It's free online, actually. It's from the US government and set data. So what about the attributes of the dimension? So how do we get hold of the attribute dimension? So data dot variables, because longitude is also an actual variable in your data. So you use the name of your variable, LON in here, to refer to a certain variable, and then further another dot, the second dot in here, and then attributes. You will get the attributes of the longitude. So it's giving you the units, the name, so different textual information. What about the attributes of variable? It's just exactly the same as the previous slide, just changing the name in here. Double quote, remember to double quote, because this is a string to store the variable name. Okay, it's giving you different things. For example, the units, you know that it's degree Kelvin for your data. The long name, it's air temperature, it's not the ocean temperature, right? It's for the surface level, so different information for your data. Okay, so how do we read the attributes? Most of the times we don't need to read them, but here is just showing you how we read them. So again, it's data set. Variables refer to a certain variable using the string and attributes, and then you can use a bracket in here again to refer to a certain attribute. So valid range is in here. I've highlighted that valid range. So you can see that they are all inside a quote, which means that they can be referred to by the string in here. For example, if you want to find a long name, just put long name in the bracket after ATTRS in here. Okay, and because this valid range is an array, so you need to have the indices of your array. Okay, so you're printing 185.16 and 331.16, which is coming from the array in your valid range. You probably don't need to read this. When you have to use it, you can check the menu or you can check my slides. Okay. Okay, so next is the numerical information. How do we extract the variable? So this is the main dish of the whole lecture. How do we get the numbers for further calculation? So here is how we get the data, right? Data, and then you use the variable name to refer to the variable, right? And then because your variable is a 3-dimensional variable, you need to, for example, a certain value inside of your data, you need to have the indices. 2 to 5 for the first dimension, which is talking about time, right? The second dimension is just 3. So it's just random numbers in here. I am putting random numbers. They don't mean anything, but just showing you the example. And then 4 to 8 with a step of 2. Okay, so it's a crop data. We have extracted a part of the data out and then put that into another variable. Okay, so when you print this crop temperature variable, is still an object. It's not an array here. It's still an object. When you print that, it will give you the exact same messy stuff in here. So the information of the data from which time to which time, and then for which latitude. Why do we just have one latitude in here? Because we have put 3 in here, right? We just extracted the 0, 1, 2, 3, the 4th latitude in your data. And then 4 to 9 with a step of 2. So it's giving you some part of the longitude. Okay. So next is exactly the same as the previous slide, except that now we can tell the computer which dimension you're talking about here. You don't know the dimension, right? You have to know the order of your dimension in your data. Of course, it's just time, latitude, longitude, time. The second one is latitude. The third one is longitude, right? So it turns out that you can be not knowing the order of your dimension. You just know the names, and then you can put it in different orders in here. It doesn't have to be time, latitude, longitude anymore. You can put it in different orders. And so here we are using the form of dictionary to refer to a certain dimension, so time dimension, colon in here, and then range 2 to 6. So it's exactly the same as the previous data cropping in here. So you can see that it's extracting 4 by 3 data and also 4 by 3 data. I think it's exactly the same. Yes, it's the same latitude and the same longitude. When you do this, it's just clearer to do that. Okay, so what would be the type of your data? I've just mentioned this. This is not an array. Even though if you have cropped the data, it's still an object. When you print that, you will see that it's not giving you the actual 12 values. The 12 values are here. They're showing you, okay, you have 12 values, but we're not printing that for you. You just know the information. Okay. Any questions so far? It's a bit complicated, actually. Okay. If you can follow, please raise up your hand. Okay. So, here it poses a problem in here because you don't know the time, right? You just know that, okay, from 2 to 5, but what would be the time? Okay, most of the times you don't know the order of your time in your data. For example, I want to extract. So it's human language to say that I want to extract January, for example. I want to extract January the 1st. So it turns out that you can do that. You don't even have to know the indices in your data for January the 1st, for example. So how do we do that? For example, of course, you know Hong Kong latitude, right? Longitude. So sometimes if you want to just extract a certain latitude, longitude, how do you do that? This is not human language, right? You don't know the indices inside right away. Of course, you can print the indices out and then you can find the indices that you want, right? But that's not convenient enough, right? Okay, I've just talked about the next slide. I think I have to talk about this slide first. So this slide is exactly the same as the previous crop temp tool in here, except that we are extracting the actual value. So you have to dot values after that to get the NumPy array. Now you know what you're doing, right? You are extracting the array, not the Xarray object. You're extracting the array, then you know how you can deal with the NumPy array for further calculation, because you know how to deal with this, right? We have already learned about NumPy array. So this is when you print this crop temp 3, you will see that there is no longer an object. It's not an Xarray object. You can do calculation with this array in a 2D array in here. When you use the type function, you can find that it's a NumPy array. So the next question I have just talked about. So do you actually know the time, latitude, longitude of your crop data in here? You don't know that, right? Just know the indices, 2, 3, 4, 5 for time, and 3 for latitude, 4, 6, 8 for longitude. So that's not okay, right? It's not human readable. You don't know the actual values. So how do you use the actual values? For example, I want to read the longitude 10 to 20 with a step of 5. Okay. It turns out that you can do that with adding this .loc in here. There's no LOC in the previous slide, right? So this LOC, it means location. So it's going to help you to use human language to read your data. For example, here you actually know the latitude that you want. You actually know the times that you want and the longitudes that you want. You don't need to know the indices anymore. You're using this LOC, square bracket, and then this curly bracket. So it's very important to use the brackets right, okay? Here it is also using square bracket and curly brackets. Okay, remember that. But there's no LOC in here. So there's a .loc in between here. And then you can use the actual values, not the indices anymore. And still you have to dot values to get the NumPy array. So now you're getting the NumPy array. So the crop temp 4 here is giving you the NumPy array. It's exactly the same as the previous results in here, but it's no longer requiring you to input the indices in here. You don't need to know that. You just need to know the times, the actual times, latitude and longitude. Okay, so now we get to the part which is very useful. For example, I want to get a range. Okay, I know the range of longitude, for example, in the Western North Pacific. I want to know the average temperature of a certain box on the map. So how do we do that? We use Boolean indexing. You have already learned about this. So we extract, first of all, we extract the values for latitude and longitude first, put it in a variable, long C and let C in here. And then we use the Boolean indexing. For example, I want to get the data between 40-degree longitude and 48-degree longitude. So within a range, you know the range, okay? And then we use this result. This result would be some trues and false, right? And then put that back to longitude. What do we get? We get a subset of your longitude where is between 40 and 48-degree longitude. So if you do this, the required longitude here will be giving you 40, 42.5, and so on and so forth. Okay, so the conditions are set by you. Okay, and then we do the same for latitude. For example, you want to get the latitude larger than or equal to 80, it will give you the values and then put that into required latitude in here. So inside your bracket is the mask. I hope you remember that. Okay, the mask are containing the trues and false. Okay, and then we put that back to what we did in the previous slide. okay, because we have the range, right? We have the range of latitude and longitude. We put that back. We require latitude in here, we require longitude in here, and then we can extract this prop value, a certain value, some values in your data. Okay, here, this one. I think it's not exactly the same as the previous one. Yeah, because it's extracting a different areas, not the same area as this one. Okay. So when you are modifying your data set, so here is how we can modify the data set. We are talking about certain value in your data. So this is still using the indices. And then we modify the data by assigning a new value to say 64.15 to a certain value. Originally, it was 263 something. Okay. Whenever you are doing this, you are just like what you did with your Microsoft Word. When you are typing, it's not saving anything in your hard disk, right? Except that if you have autosave, okay? When you're typing in your Word and the words that you're seeing on the screen, where are they in a computer architecture? They are in a RAM memory. When you turn off your computer, they're gone. That's why when you do your homework, most of the time you hit save a lot. When you hit save, your data will be stored in the hard disk. Okay, so just like that, if you're modifying your data like this, you're just modifying the values inside your RAM because data is loaded into your RAM only. It's not stored in the hard disk, which means that it's not stored in your NetCDF file. Okay. So still we are working in the RAM. So how do we append new data set, new data variables? So here we are trying to make a new variable, temp SFC underscore degrees Celsius. Let's say if we want to have another exact same variable, except that it's with a different unit. So this is how we do that. We make use of the old structure of the old variable, the structure of the old variable here, temp as FSC and make it 0. Okay, multiply by 0. And then assigning that to a new variable. And then of course we need to do subtraction because it's a new variable, right? We need to do some calculation to turn that into degrees Celsius. And then we change the attributes to degrees Celsius. You will have to do this for your homework, okay? And then when you print that, when you print your variable, the two variables in here, they're giving you some reasonable numbers, right? The temperature in degree Kelvin and temperature in degrees Celsius. And then when you print your new variable, the attributes of the new variable, you will see that the units will be turned into degrees C because this is what you give, right? This is what you have given to the data. Okay, so now we are turning the data to the hard disk, which means that we are writing the data in your storage, in your more permanent storage. Okay, so we use data to NetCDF, just like last time, data to CSV, and the new data variable name. And this is default. You have to put this unlimited times. You're telling the computer that this dimension is unlimited. It doesn't mean that it goes to infinity in time. It just means that you're stacking your data on this dimension only. Okay, you're not adding more latitudes and longitudes in your data when you have new data. Okay, and then if you want to know more about your new data set, you can do exactly the same operation at the beginning of this lecture. So open your data set and then print the information. Now you can see that there are two variables instead of just one variable, right? You have just added one variable. Okay. I think there are some more following, but I'll give you, now is the time to do the exercise. Okay, exercise 1A and B first. Okay. Okay, I think most of you have finished a part of the exercise 1 and 2. So now I want to finish the rest of this lecture, which is the date treatment. So this is a lot more complicated than the latitude and longitude, because time is like an irregular dimension, right? It's not going in increasing or decreasing order like you wish. So we need different treatment for time or date. Okay, so in the previous slides, we have used the format of time here, year, month, day, and time, right? Usually it's the 0 minute and 0 second for time. So in Python, day is a daytime object. It's actually, we have to deal with time with using some object, some kind of library, okay, with special format and methods. So this is shown in the previous slides, right? The time. So here we are trying to make a list of date time. For example, if we want to make a list of time with the beginning time is June 12, 12 o'clock, and then June 12, 1 o'clock in the afternoon. So what is T0 in here? T0, which is the beginning time. So the beginning time, of course, is the June 12, 12 o'clock. And there are two ways to make a list. The first way is to have the delta T, T0, and number of data decided. Or the second case is that we have delta T decided, T0 decided, and the last T, which is 1 o'clock in this case, right? And what would be the n in this case if we have the intervals of 10 minutes? 1, 2, 3, 4, 5, 6, 7, 7 data points in here. So n would be equals to 7. So you have to either be case 1 or case 2 to make a list of time. Okay. So there are two cases. So for the first case is that we know delta T, we know T0, and the last T. We do not know the number of data in here. We don't know the number of data. We just know the beginning, the end, and delta T. Okay. So how do we do that? We have the start time, T0, end time, last T, year, month, day, hour. Usually it's 0 minutes, so we don't need to tell the computer that. And we make an empty list first in here. This list is empty, and we know the delta T, right? It should be given. And we start a loop here, a while loop here. Start the while loop with the first day being the start day, which is T0, year 2019, June 12, 12 hour in the afternoon. Okay. And then we make use of this while loop to append the time each time to the to the date list in here, DT list in here. It was originally empty. So we added the time each time. You don't need to know, actually you can make use of this while loop. You can copy and paste this while loop when you make a list. You don't need to know the exact way of how I did it. But this is how we turn the date into the ISO format, which is the year, month, day, hour, to a datetime object. A datetime object, put that in T. And we append this datetime object to your D list. And then we move forward in time here, the third line inside the while loop. We move forward in time by using the library, datetime library in here, datetime library, and time delta, which is a function inside this library. And then we know it's 10 minutes, so minutes equal to 10. So the argument here, this is a name argument, right? We sometimes need to use the name argument. We have decided that the time, the delta T would be 10 minutes. So minutes equal to 10 here. So move forward in time. So if you don't understand, it's fine. Just use this while loop to make a list of time. Okay. And of course, you need to have the start and end time. Okay. After that, when you print the list of time in here, it would be the time that you have asked for, right? 1, 2, 3, 4, 5, 6, 7, 7 data points. It should be 6, right? 6, 10 minutes in 1 hour, but we have included the last endpoint in here, which is the starting hour for the next hour. Okay, so 7 data points, 7 datetime object is actually a list of objects. Okay. So we can, okay, to make use of the while loop in here, I have put that into a function. So if you want to use this, it's fine. Just copy and paste this function. The input of this function is start time, end time, and delta t. So you just input these 3 and then copy this function into your program. You will get the datetime object list. Okay, so you have to specify the start time here using the datetime function from the datetime library. Specify the start day, end day, and also delta t. So use all these functions, datetime and time delta function, to set the start time and delta t. And then use this data range that has been pre-written for you. Just copy this if you want to use it. And then put the start, end, and delta t. It will give you the range, right? The output, we are returning the datetime list. So the output of this day range function would be this list. Okay. Usually I would ask you to write that, but it's okay if you want to use my function in here. Okay. So for the time selection in an NC file, it's depends on how you make the day list. So let's say if you have pre-written this day range function, you can use it. Just input start day, end day, and delta t, and then put that in your, just like require lat long, you have done exercise 1B, right? If you have done the require lat long, you know what we're doing here. We are trying to put up a date list that for the time that you want to get from the data. So use LOC. So day list is actually containing the actual dates in here, actual date and time here. When you do this, you're extracting what? 12 hours from 11 date, 11 and 13. It will be 5 data points, right? 11號到13號，12點，即係12個鐘1點，咁咪前後4點，再加最尾個點5點咯，5點 data，OK？ 00點、12點、00點、12點，再最後一日00點，11到13號，係咪？ That's it, right? That's how you get the data within a day range. Okay, so next is creating new data set. This is starting from scratch. If you have no data, nothing at all, you're starting to have like an empty box so that later you can put data in. So this is how you do it. You first of all set a new data set in here, Xarray data set. And the data vars is how you set the new variable. So the first variable is named zeros, second variable name is ones, and then third variable is named twos. And then after that, you will have to set their latitude, their dimension for, the dimension for the first variable, the dimension is latitude and longitude. For the second variable, ones, the dimension is just latitude, okay? So you can have different dimensions for different variables inside your data. And then after that, that would be the actual values. Because I've named your variable 0, so I've given all of the variables to be 0 in your data. So why is it 5 times 5? 5 by 5 data, because I have set the size for latitude and longitude to be 5. Right, range 5 is 0, 1, 2, 3, 4, right, which is 5 values. For the longitude, also 0, 1, 2, 3, 4, so 5 values. Which means that your zeros, this variable here, has to be 5 by 5 because you're telling the computer that there are 2 dimensions for this variable, latitude and longitude, right? And for the next variable ones, it's just have 1 dimension with the size of 5. So you just need 5 values in here to put inside. So when you set a new variable, you need to give the computer the name of the variable, the dimension of the variable, and the actual values. So 3 things you need. And also another part for this data set is the coordinates, the name of your first dimension, values of your dimension, which is the coordinates, name of your second dimension, and then actual value of your second dimension. So when you print this data, what would you see? 5 by 5 0 values, which is set by your first line in here. Okay, and then for the ones, it's just 5 values of 1, which is set in here, mp.ones. And here, twos, the variable twos, it's just 5 values because you only have 5 values in the longitude, right? And I've added 2 to the 0, so you have twos in your variable. And then you can write your data. The data set is stored in new underscore data underscore 1. Okay, and then you write that to a NetCDF file. It's pretty standard. Okay. So what if you don't need the new latitude and longitude? You just need to copy the old latitude and longitude from the old data set. So you read the old data set, and then you get the coordinates lat and long, save that to another variables, other variables, and then you will input that as the latitude variable and longitude variable in your coordinates for your new data set, new data tool in here, right? You don't need to set the latitude and longitude, just copy the latitude and longitude from the old data. Okay, that's it. Okay, what if you want to copy the old variables from the old data? It's pretty easy, right? You have the old data in here. I've actually named that old data, the data set old data in here. Okay, so you will read the latitude and longitude from the old data. And okay, this is just copying everything. Okay, copying the this is initiating a new data set in here, Xarray data set. So new data free is a new data set in here. We are copying the old data attributes to the new data, and old data a certain variable to the new data, the same variable name. You can have a different variable name in the new data set. Okay, and then that's it. You don't even need to copy these two, actually. When you copy the old data, temperature, surf, SFC to the new data, it will automatically transfer everything, the metadata. Okay. Okay, what if we want to modify an attribute? We copy the old data to the new data set, and then we copy the attributes here, the old data attributes to the new data, and copy the old data, a certain variable to the new data. So now you have completed everything, right? They're exactly the same, but then you want to edit the long name of this variable in the new data. So this is how you do it. Nothing you haven't learned before. I've already talked about this actually. So this is just repeating, okay? Edit the long name, just assign new variable to this long name. And then when you print the new data, you can see that the long name is edited, is modified, right? We have given that copy 4 times daily air temperature 995, which is this one. Yeah, I think Yeah, you have 3 parts for the second question, and that's it. Any questions